Okay, here we are at part 2 of the Friday lecture. I just reviewed part 1. Sorry for the stuttering, sorry for the glitches, and it was really painful for me to watch myself in the lower right-hand corner of the screen, but I'm still learning. Okay, so let's try another sample problem. Here's a problem that comes from our textbook. It's problem 46 out of chapter 13. Okay, we've got a 4-ton lunar lander. It's in a circular orbit 50 kilometers above the surface of the moon. The lander needs to move out to a 300-kilometer high orbit in order to dock with the mothership that will take the traveler home. How much work must the thrusters do? Okay, so remember, by work is an energy, so we're asking how much energy must be burnt in our thrusters in order to boost that lunar lander to a higher orbit. Okay, now work implies energy, and the first thing you do whenever you're solving an energy problem, well, we hope we can use the conservation law, so we don't draw just one picture, but we draw two pictures. We're going to draw a before picture and an after picture. So let's give this a try. Okay, we're going to draw the moon. And the lunar lander starts at a certain height. I'm sorry, conservation of energy problem. So we're going to draw a before picture and an after picture. So in our before picture, the satellite is a certain distance away from the center of the moon. We're given that it is 50 kilometers above the surface. In our after picture, the satellite is now 300 kilometers above the moon. But we know whenever we're dealing with gravity, we're really interested in its distance from the center of mass. Let's call this distance right here R1, and let's call this distance over here R2. And this would be the after picture. Okay. So we've drawn a before picture and after picture. The next thing we're going to try to do is we're going to try to figure out how the energy is going to work. And what we know is that the energy before has to equal the energy after. And in the before picture, the satellite is orbiting the planet. It's orbiting the moon. So that means it's got to have some